All right, let's talk about building event-driven systems. Not the kind that just look good on a whiteboard, but the kind that can actually survive and even thrive out in the wild. We're going to dig into why these systems so often break under pressure, and more importantly, how we can architect them to be truly resilient. So, let's just jump right into a scenario that probably keeps a lot of engineers up at night. It's Black Friday. Traffic is hitting 5 times your normal peak. And then, it happens. Your services start to buckle. Functions are timing out. Queues are backing up. And worst of all, actual customer orders are failing. This isn't just a hypothetical, right? This is the kind of stuff that happens.
And what's frustrating is that when you look at the design, it seems perfect. It's beautiful, really. You got a producer firing off events, a queue that acts as a buffer, and a consumer that processes them. It's decoupled, it's supposed to be scalable, it looks so clean and simple. But if the design is that straightforward, why does it all fall apart when things get real? Why do those orders start to fail? Well, the answer isn't in that neat little diagram. It's buried in the messy, chaotic reality of how these systems actually behave when they're under stress.
See, the problem isn't the basic producer-queue-consumer pattern. The problem is the fragile foundation it's built on. It's all the hidden architectural debt and the faulty assumptions we make that turn our perfect system into a house of cards. So let's break down where we usually go wrong.
First up, the biggest mistake. We design for the average day. We tune everything, our batch sizes, our memory, our concurrency, for that nice, predictable 50th percentile of traffic. But, as the source article rightly points out, real-world traffic is anything but average. It's spiky, it's unpredictable, and when that 90th percentile tsunami of traffic hits, a system that was only built for a calm sea is guaranteed to sink.
So what's our go-to fix? Simple retry logic, of course. But this can be a total trap if you don't implement it carefully. With things like exponential backoff and jitter, retries can actually make the problem 100 times worse. You end up creating these invisible retry storms that just hammer your downstream systems, turning a tiny hiccup into a massive cascading failure.
And this brings us to another huge risk, treating every single event like it's equally important. A critical payment confirmation is not the same as a low-priority logging event, right? But when they're all stuck in the same queue, you risk your most important business functions getting starved out, just sitting there waiting in line while the system is busy retrying some trivial task.
The source article has a great term for what happens when all this pressure builds up: metastable failure. And trust me, it's as scary as it sounds. This is when your system tips over from being stable into this really vulnerable state where even a small trigger can cause a catastrophic, long-lasting outage that won't fix itself. It needs a human to come in and basically pull the plug to reset things.
Okay, so how do we get out of this mess? How do we start architecting for reality instead of for a perfect world? Well, the solution isn't some single magic bullet. It's about building a multi-layered defense using proven patterns at every single level of your stack. Our first line of defense starts way before we even think about infrastructure. It's all about using smart design patterns to weave resilience right into the core logic of our system. And one of the most powerful patterns here is called shuffle sharding. Now, instead of just lumping customers into a few big queues, you assign each customer to their own unique, random subset of resources. The absolute genius of this is that it massively reduces the chance that one noisy neighbor, one bad actor or buggy client can overwhelm a resource and take down a bunch of other innocent customers with them. It contains the blast radius. It's brilliant.
Okay, next up is our infrastructure. We've got to stop thinking about it as just servers and databases. It is a powerful tool we can use to absorb pressure and shield our core application from ever getting overwhelmed in the first place. A great way to use infrastructure is to really lean into the idea of queues as shock absorbers. Think about it. Services like SQS or Kafka are perfect for soaking up those crazy traffic spikes, which gives your consumers much-needed breathing room. Plus, they come with built-in defenses like dead letter queues to isolate those nasty poison pill messages and FIFO queues to make absolutely sure your critical events get processed in exactly the right order. And that brings us to our final layer of defense, the operational patterns. This is all about controlling how our system actually behaves when it's under stress. It's about making sure its failure modes are predictable, manageable, and most importantly, recoverable. And the fail-fast pattern is just non-negotiable here. If a consumer knows it's in trouble, maybe a database connection is down, it needs to fail immediately. Just throw an error and stop. This prevents it from just hanging there, holding a message hostage and triggering a long, painful timeout. By failing fast, you stop wasteful retries, and you send a clear signal to the rest of the system. Hey, back off.
which allows for a much faster recovery.
So when we put it all together, you can see this powerful, layered strategy emerge. At the design level, we're using shuffle sharding to isolate failures. At the infrastructure level, our queues are absorbing those painful load spikes. And at the operational level, fail fast ensures that when we do fail, we recover predictably. It's not about picking just one of these, it's about how all three work together to create a system that's genuinely tough.
But here's the thing. Applying these patterns is only part of the story. The real secret, the key to unlocking true resilience, requires a fundamental shift in how we even think about failure in the first place. The source article puts this so perfectly. You can intend for your system to be resilient. You can even design it with all the best intentions. But only deep, meaningful observability will tell you if that's actually true when the pressure is on. And real observability isn't just a dashboard with error rates. It's about asking yourself these much harder questions. How fast can you even detect a problem? Once you've detected it, how quickly can you recover? When something does break, is that blast radius really contained or is it spreading? And be honest, are your retries actually helping or are they just kicking the can down the road? These are the questions that reveal the truth about your architecture.
And that gets to the absolute core of it. We're not trying to build some mythical, perfect system that never, ever fails. That's a fantasy. Resilience isn't a feature you can just bolt on at the end of a project. It has to be a fundamental mindset from day one. The deep-seated assumption that failure isn't an if, it's a when.
And that's really the big takeaway here. Resilience is not about avoiding failure. It's about building systems that can take a punch, that can degrade gracefully, that can contain the damage, and that can recover automatically. It is all about surviving failure. And that, right there, is what separates a fragile system from one that is truly built to last.